Welcome to this tutorial about FicsIt-Cam, a camera animation and manipulation modification for Satisfactory. FicsIt-Cam adds tools and utilities allowing you to manipulate and animate the camera inside of the game in multiple different ways, allowing you to create beautiful cinematic camera shots as well as to do some live production. One of the most important concepts in FicsIt-Cam is the concept of a scene. A scene is essentially just a couple of parameters the scene might have, like resolution, frame rate, stuff like that, as well as a list of so-called scene objects. A scene object is anything that can be placed essentially into the world or just added to the camera scene dynamically. And you can add multiple different scene objects of the same type, doesn't matter. These scene objects might have a name. You can order them, they can be activated in different orders, and these scene objects can be stuff, for example, like an object that controls the world settings, like the time of day, or it might be a particle system, or a camera object you can animate, and when you then play a scene, it will then use the most active camera and essentially uses the most active camera scene object and uses this this scene object, the rotation, location, field of view and stuff like that, to move around in the scene to then create an animated camera shot, for example. When interacting with FicsIt-Cam, the most common way to interact with FicsIt-Cam is to use the chat window of the game. There, FicsIt-Cam adds a couple of new commands. The most important command and the base command of all other commands is the FIC for FicsIt-Cam command. This command then takes a couple of sub-arguments and sub-commands to allow you to further specify what you actually want to do. For now, we want to create a new scene. For this, there is the FIC create command. You can see it then takes a scene name. Every scene or a scene object or a time-lapse camera or camera feed or whatever uses the same naming scheme, which can be any ASCII numeric character and the underscore. So you can have stuff, for example, like meep123 underscore. But what you cannot do is like meep-123, because the dash is not an allowed character. Only alphanumeric characters like this uppercase and lowercase letters and and then the normal 10 digits as well as the underscore are allowed. We're gonna create a scene and we're gonna call it test. If you hit now enter, you can see scene test created. You can copy a scene using the FIC copy command, where you then provide the old scene name, and then the new scene name. We can now say FIC copy, and then we're gonna say test, and then we're gonna move it to, and then we and then we need to provide the new scene name for the new copied scene, which is, in our case, let's call it OK. And then you can see scene test copy to new scene OK. Now we can also rename a test instead of just copying it by using the rename command. There we then provide the old name and then we give it a new name like OK123. And then you can see scene OK renamed to OK123. Last but not least, you can also delete already existing scene using the delete command. You can then just simply provide the name of the scene you want to delete. In our case, the OK123 scene. And you can see scene OK123 deleted. You can also list all currently existing scenes using the FIC list command. There you can see we have a scene called Meep, which I already created and we will use later, and our just newly created scene test. So now let's finally edit a scene. We can use the FIC edit command to start the edit mode for a given scene. In this case, we want to edit the test scene. Here in this scene edit mode, you can see a lot of new UI got added, and you can also normally navigate around, like theoretically. So you can see I can use my mouse cursor right now to look around. You can also see I can move with WASD around, and but you cannot open like a map, the in-game menu or whatnot. So these inputs are disabled and replaced by some FicsIt-Cam shortcuts, etc. For now, you can use Q and E to roll your camera, and you can also press escape to get your cursor. Now that you pressed escape, you can now move your mouse around, and you don't move inside of the viewport anymore. Inside of the game here, you cannot look around, but you have your cursor now, so you're also able to interact with this new UI over here. When you want to go back and being able to navigate around, you can press by default, so you can change these many of the FicsIt-Cam controls, especially when you're in the viewport here. The viewport is everything where this 3D world resides in. So like this whole large window here, this is called the viewport, and we are inside of the viewport. When you have focused it, you can then use some shortcuts, and you can change these shortcuts in the game's control settings. So for now, if you want to like snap back to be able to look around, you can press the G key on your keyboard, and then you can look around again. You can then press either escape to get the cursor back, as I already mentioned, or you can press G again and then also get the cursor back. But this is quite bothersome when you want to move around a bit just for a small little change. This takes quite some time to then always press a keyboard key. What you can do instead is you can also press and hold the right mouse button onto the viewport. When you now hold the right mouse button, you can now look around, move around with WASD, Q and E, stuff like that. You can simply do everything as we already know. And when you then release the right mouse button, you get the cursor back at the exact same location where you started to click. And with this, you can way more easily do some changes, get directly back the cursor to then head over to the UI, instead of always having to think about pressing a key. You can see that the UI consists of a lot of different panels. Even the viewport itself, by this triangle here, is a small little tab or panel by itself, as well as this large panel down here. This is also, now you can see this is the timeline panel. You can close them back by right click and then hide tab. This you get the triangle back, and it consumes less space essentially. This is the new tab and panel layout. You can move things around, so you can like change the sizes of different things. You can stack them into such a tab list. You can like position them to like capture 1/2 or whatever. You can also do the same thing for over here with the viewport if you want to. And you can now store this layout of panels. For this, on the top there is the menu bar, and then there is the section of the layout. In here you can like restore the default layout, but you can also store a layout. For this you go to manage layouts, new layout, and then provide a layout name. We're gonna call it Meep for now. You can click on store layout. Now, when you go open the layout menu again, you can see now there is a Meep button. So if I change the layout for whatever reason, for example, and now I want to go back to our Meep layout we just previously had, and now click on layout, and click on Meep, and it restores that layout from previously. You can also revert back to the default layout by clicking on default instead. You can store multiple different layouts, not just one, by just simply adding a new layout with a different name. Test or layout, and now we can now switch between the Meep layout and the test layout, or going back to the default layout. The default layout cannot be removed. If you want to remove such a layout, you go back to manage layouts And then you can click here, either remove me or test or whatever layout you want to remove. And then can remove the layout this way. Also worth mentioning is that when you move around, without storing a layout with the manage layout section here, and you change your layout here, then you close the editor, close the game, open the game up again with the same save file, and go back into the editor, it will still use the old layout of which you're left off. When you messed up something, you can still, as said, return back to the default layout by clicking on layout and then default to revert back to the default layout. When you've closed some tabs like this and you want to reopen them, the way to do that is you go up to the main menu, to the menu bar, click on View, and then select the different panels you want to now have been added back. You can close this scene editor by clicking on the main into the menu bar on the exit button. Now you're back in the game and you can use your normal controls for the map and stuff, do your normal interaction, building things and whatnot. But if you want to go back to the editor, you again have to call the edit command. Let's go through some panels. The first panel I want to talk about is the timeline panel down here, which is this large panel down here. This is divided into 3 sections. The first section is this timeline details section. This timeline details section allows you to change, for example, the animation range. That means like the start point of the animation, the end point of the animation. This also means you can here change the length of an animation. You can also change the active frame range. The active frame range essentially is just essentially a range of the timeline you want to focus on. It could be larger than the whole animation, to also look at some outside part of the animation, or you can say you just want to focus on the parts of the inside of the animation. You can just look at one particular part or section of the animation using this active frame range. This is especially useful in regards of the timeline scrubber and the graph view, of which we're going to talk about in a second. You can also change the current frame. The current frame is, you could say, the current time inside of the animation. When you change the current frame, you can drag this value here around. So each of these numeric values here, you can either click into it and then enter the numeric value directly by typing it out, or you can drag it around. You can see I can now drag around the current frame here. So right now our animation goes from frame 1 to frame 300. And we can now set the current frame to something in between or even outside of it if you need to. But with the current frame, you can say where inside of the animation you want to be. Because we can edit the whole animation at any point in time of the inside of the animation, we have to define at which point in time we actually want to have a look at in the viewport. So like when the viewport says the camera should be at this position or the camera should be at this position, we want to see how this would look like. We have to define at which point in time we actually want to view the world from inside of the animation. This is done by the current or active frame. By setting this, you can say, okay, at which point in time of the animation you want to have a look at the scenery. This will be made more clear when we then actually create our first camera animation. We should also now talk about what a frame is. A frame is just simply one increment of a time. So instead of saying you can also increment the time by a tenth or whatever, this cannot be done here. You are limited to one frame of a time increment. If you're just playing animation in real time using the play command, it will try to goes even smaller steps, so you can also have even more frames if your computer is able to render those frames. But for defining when what should happen inside of the animation, you are fixed to these frames. The speed of an animation is then defined by the frames per second of a given scene. By default, this is 30. So that means you have 30 time increments that will happen after each other inside of 1 second. And this is essentially how much detail in regards of specific key changes you want to add to your scene. Between such key changes, also called keyframes, stuff will be interpolated. We will talk about that at a later point in time. For now, it's important to understand that you can only specify a change of a value of like the location or whatever of a camera. Can only be done at the increments of frames, which is by default 30, but you can change that to other values, whatever you want, like 60 frames per second. Then you can do some 60 key changes in a time, at in a point in time, in a frame. When you render out an animation, then these frames are also, then each frame is also like one image file created for the image sequence that will be rendered. The arrows left and right to the current frame just simply allow you to play the animation as a preview inside of the editor. If you click on the play button, you can see it runs with 30 frames per second from left to right. When you hold Control and click on it again, you can double the speed. Now it's triple the speed when you click it again, and so on. You can increase the speed of the playback, allowing for a quick check. This essentially allows you to quickly check if everything is right of your whole animation when the animation is like 10 minutes long. With this, you can have a quick overview over everything. When you have 10 times the speed, then it only needs 1 minute to have a look at all the animation. So this allows you to do that. When you want to stop the playback, just click the button again, like that. Now it's stop the playback. Click it again, starts the playback. Click on it again, stops the playback. You can also reverse play it by using the reverse play button over here. Then it just simply goes from right to left. And also hold Control to increase the speed. When you now click on the other button, it will just simply stop. And when you then click on the other button again, it will continue. When you have increased speed, you can hold Control on the opposite direction button to decrease the speed. Not directly stop it, but you can use this to decrease the speed instead. The attributes shown in graph view section down here essentially allows you to specify what attributes and attribute groups of a given scene object you want to have been shown in the graph view. What this actually means we will talk about when we have an in-depth look onto the graph view. And we talked a bit about the graph view. We won't go into in-depth here, but the graph view is this second section of this timeline panel down here with all these colorful lines and this grid here with some highlighted space and stuff. This here is the graph view. The third area of the timeline panel is this part up here, these two rows here, which are also called the timeline scrubber. The lower row is called the frame selector. This essentially just simply allows you to, like the current frame slider over here, to change the current frame. But the frame selector down here allows you to do that in regards of the active frame range. As said, the active frame range is just simply a range of time you want to focus everything onto. This scales this frame selector as well as the graph view down here. So when we now make the frame range a bit smaller to be just one small little section inside of our animation, like here from frame 55 to 110, you can see when I now move the frame selector around, we are just from left to right, we're only navigating the camera frame between those few start and few end value in between, because we said we want to focus on this small little section of the animation. Now you may already have noticed that the above row also has changed a bit. So the above part here is the active frame range selector, and this essentially allows you to change the active frame range using like these few start and few end values, but in a more graphical and more easy way to understand. So note here, left and right of this row here represents the start and the end of the animation. No matter what settings you used here for the animation end and start values, left and right here will represent start and end of the animation. And this highlighted range in between here in the frame range selector essentially is now the active frame range where you want to focus on. You can see when I now take the frame selector and go all the way to the left, we are essentially at the left of this frame range selector over here. When I go all the way over to the right, we are at the frame range selector range over here. So with this we know, okay, so we are inside of the animation, but like we are inside of this frame, we are just looking at this small little part of the animation when we are using the graph here or this frame selector above here. So we're only looking at this small little section of the animation and not the whole animation. You can do some interactions here. So if you click somewhere on this line, just a simple click, you can change the current frame to be at this exact location. You can change the current frame this way. You can also click here inside to do that. You can also hover over that orange bar, which represents the current frame, and then drag it around. So if you hover over that orange bar exactly, you can then drag it around. You can also interact with this highlighted range, as you already just seen. So if you click and hold just somewhere inside of this range, you can move this active frame range around. You can also resize it by taking one of these handles. Grabbing that allows you then to increase or decrease the animation range that way, if I'm able to click on it. You can see now I can change this frame range. You can also see down here how the graph view scales around depending on what values I change here now. This works on both sides. The frame selector down here also has a very similar functionality, but just for changing the current frame. So you can click somewhere in here to directly make it jump to that location, or you can drag it around. The frame range selector also has one more interaction, and that is when you double click onto this frame selected range, it will just simply set the active range to be exactly the whole animation, essentially. You can also see that if the active range is larger than the animation, or like goes outside of a part of the animation, for example, I go here to -50, but the animation essentially ends in that direction already when we are at frame 1. Then you can see the frame selector as well as the graph view to have a small little highlighted area. So this darker part essentially is not inside of the animation, but this more light gray area here, this lighter area here, this is inside of the animation. And then dark again outside of the animation. Now let's talk scene objects. For this, there is the Scene Object Outliner panel. The Scene Object Outliner panel is essentially a list of all the different scene objects you have now added to the scene. You can see you can also interact with one such an entry, like this camera here. By default, there will already be a camera scene object added. So when you newly create when you create a new scene, then there will automatically be added a new camera scene object with the same camera settings like rotation, location, field of view, and stuff like that. At what where your character looking at when you created the scene. So we essentially copy this information and then create a new camera scene object out of it. You can click on such a scene object now, a simple left click, and you can directly some other stuff happen. So first of all, there is now this scene object details panel, which will now be filled with all the different attributes and properties the scene object might have, and you can change. So normal parameters cannot be changed, but most of the other values, which are called attributes, can be changed over time. So like these can be animated. We'll have a look at those more in depth later on, but for now, attributes are the things you can animate inside of a camera and inside of an animation. So like these values can be made to change over time. Normal parameters, on the other hand, cannot. For example, we have a particle system scene object that allows you to define a particle system you want, like sparks and whatnot, but you cannot change the type. So you cannot switch from sparks to then fireworks inside of an animation. You would need a separate particle system scene object for that. You can also see that when we have selected a camera, this only actually happens right now when you select a camera, that the viewport gets a new small little window down here, which shows what the camera shows. Right now, this is nearly the same as it is shown in the viewport itself. This is also called the camera preview. You can disable this. For this, you have to have a look at the editor settings panel down here. The editor settings panel just has some settings you can change that are only specific for the editor. When you edit a scene, then these changes just simply change what is shown and what not, and how some things behave. For example, the enable camera preview option allows you to disable this very camera preview. You can click on it to disable that camera preview and click on it again to enable it back. There is also the force resolution setting. This force resolution setting allows you to crop the viewport essentially to be with the same aspect ratio as it is defined in the resolution settings over here. In the scene settings panel, there are a couple of attributes and not attributes, but there are a couple of parameters that are specific to a scene. For example, the cinematic camera should be used, the bullet time effect should be used, if the animation is looping, the frames per second, and the resolution that will be used. So this resolution setting mainly allows you to specify essentially the aspect ratio that is used when you use the force resolution setting or for the camera preview. But it's more important when you're using camera feeds using camera references. We will talk about those later. And when you want to render an animation. The resolution setting allows you to specify what image resolution is being outputted when you are doing when you are then rendering a given scene. The FPS already mentioned allows you to specify how many frame, or as I said, time increments per second will be used when you play an animation with normal speed. This includes like even the player preview here. So you can see we're currently with this speed, 30 frames per second, and when we change this value to, for example, 120 frames per second, you can see this is a lot faster because we are going over a lot more frames per second than before. By default, this value though is 30 frames per second. The looping option allows you, when it is enabled, to just simply tell the scene players, etc., the animation players, etc., to simply restart the animation when it reached the end. You can then create animations that essentially start at the same point as they end, and with this you can create a continuous looping animation. When you then use them in using the play command, or using a time-lapse camera, using camera reference, or feed camera using camera reference, you can then create the effect that it's constantly being animated and there will be no end of the animation. This is a bit troublesome for rendering an animation. So like if you don't do anything, it will keep rendering and keep creating image files, and that can clutter your file system. So you then have to manually stop the rendering operation. Same as for when you're playing the animation using the play command and not in background, then you also might want to stop the animation at some point to be able to play the game normally again. The bullet time option of the scene settings allow you to essentially freeze the game. This is not recommended to be used when you are using multiplayer. There are also some current graphical bugs may appear. We are not quite sure why this happens. On some systems it works. It could be due to the different graphics API you can select in the menu of the game. For now, bullet time essentially allows you to freeze the game time. When you click on it, you can see all the different animations inside of the game stopped. Particles stopped. Even factory simulation, when you have factory buildings like constructors and stuff, and moving trains or whatever, or trucks, they stop. They don't do anything anymore. They are now freezed into place. And with this, you can then create some bullet time effects, like matrix bullet time effects and stuff like that. The Use Cinematic Camera option allows you to enable a cinematic camera. Important to notice, this is activated by default, and when this is enabled, the GPU might have to do quite some more work. This is more intense for the GPU, so if the main intent of your scene is to be used with the play command to render in real time, having as many frames per second as possible, I would recommend you to disable this. If you want to enable it, this on the other hand allows you to have some more features, like depth of field effects. So we have in the camera, in the scene object details, when you select a camera, you can see we have a couple of different attributes, like a position, rotation, field of view, aperture, and focus distance. The latter three are very important when you're working with depth of field. But the field of view by itself, without a cinematic camera, also allows for a zoom effect to happen. But when you use a cinematic camera, then this field of view value should be rather low to be able to then use or have a very strong depth of field effect. So you can see I zoomed very much in. I have just a field of view of 30. And I'm very close to something nearby, which is this bush here, and some further away trees. Now I want to get some bullet time effect. For this, we're gonna decrease the aperture. I'm gonna set it to 1. You can already see some blurriness of those green lines occurred. And you can now also decrease the focus distance. I'm gonna set it to 100, and you can see the whole viewport got blurry. So I'm gonna increase this value now a bit to put this bush in the foreground into focus. And you can see we have now this bush in foreground, in focus, and everything in the back is blurry. Since this uses a cinematic camera, you might want to use the render command, because this is quite performance intense, and using the render command means no lag, essentially. Also, quickly to mention is you can hold down Control Shift while moving around in the viewport, and you can then use the mouse wheel to change the field of view. You can also just hold Shift to then double your fly speed if you want to. You can see in the scene object details when you have selected the camera here, and we set the if you have a look at the position and rotation values, and I now move around in the viewport, these values change. You can change these values because right now it's the case that the camera the currently active camera, which is this only camera scene object we have right now here, is locked to the viewport, what the viewport to the viewport view, what the viewport currently sees. We can disable this using in the editor settings the option lock viewport camera. If we disable this option, we detach from the camera scene object and now can move separately from it. And when I move around, you can directly see the camera now has this green box around. So there's a small little arrow here showing what upside is, and the small little arrow here shows in what direction the camera is currently looking at. Especially when you're detached from a camera, you can edit the scene in a bit of a different way than just using moving around to be able to define where the camera should look around. Now the actual camera preview actually makes sense. So if we select the camera scene object, you can now see, even though our viewport looks at a different point in time, in a different way, we still have this small little preview of what the currently selected camera sees, allowing us to now change the different settings to the different attributes here to exactly the value we want it to be. You can also now see that when we select the camera, also something new appears here in the viewport with these round things, and you can also hover over them and they get a little bit larger. This is called the transform gizmo, and this transform gizmo allows you to simply change the position, rotation and whatnot of that camera by simply clicking and dragging. So we can click on this green bar here to move it then along this green line, as well as like for the red thing, you can now move it along this red line. You can also click on the rotation here to then rotate it along that axis, along that ring here. You can simply rotate it like that then. You can also use this small little corner here to move it on the plane that these two small little green lines here create. You can now move it around along that plane instead if you want to. You can also drag and drop a scene object from the scene object outliner into the viewport to reposition it. It then gets placed directly onto the terrain or any object that can be seen on the surface which you're pointing at. It then gets placed to that exact position. You can see here. Important to note that this gizmo and this dragging into the scene here only works for scene objects that are 3D scene objects. For now, we only have 3 scene objects, and the camera and particle system, those are 3D scene objects because you can place them inside of the 3D world at some points. But the world settings, for example, they cannot be placed inside of the world. They are part of the world, you could say, and they don't have a 3D representation. So like you cannot click on them and they don't appear inside of the viewport. You only can look at them using the scene object details essentially, and using the scene object outliner. Now let's add new scene objects. I already talked about particle systems. So there is this new scene object panel here, which allows you to add new scene objects. When you click on one of these options, like when you click on world settings, it just gets added. Nothing really is important. Nothing really matters there. But when you click on particle system, this particle system will now be created at the exact location and with an upward rotation of where you're looking from. So if I now move around, you can see this particle system is now got placed at the exact location where I just was with my viewport camera. You can do this a bit differently when you drag it into the 3D scene. Then you can place it directly onto the ground on the things you're looking at, just when you take it from the scene object outliner and place it into the world. You can also see this only gets to the new particle system will only be added to the object outliner when you're inside of the viewport. When you drag it out, it gets removed right away again. So if you don't want to actually place it, just simply go out of the viewport, release the mouse cursor, and no new particle system got added. But when you then release it inside of the viewport, then it stays there. You can also click on most 3D scene objects inside of the world right away to select it instead of using the scene object outliner. So for example, I don't know what the name of this particle system was and what this particle system's name was. So instead, I can also just click on them to select them. I already just mentioned that, but scene objects have a name. So if you want to change the name of a scene object, first of all, you're gonna have to select it and then click on the name. And now you can edit the name. Important to notice, no two scene objects can have the same name. They always have to be different. If you still use the same name, the editor will add an _1 to it. Or it does that pretty much every time. So now I have changed this particle system's name to beep_1. When you want to remove a scene object, it can be any kind of scene object, you can select it in the outliner or the clicking it in the viewport, it doesn't matter. You can then press delete to remove that scene object. So now let's have a look at the particle system scene object a bit more in detail, because it's way more simpler than camera, for example. You can see we have a couple of attributes: active, position, rotation, and particle system. And now there's also particle system type, which is a parameter, so this cannot be animated. Position and location should be rather obvious what they do. They specify the position of that particle system in 3D space. And the particle system type allows you to specify what kind of particle system it should be. For example, in our case, this is now some weld sparks, small little sparks that are appearing here, like when you're welding something. But you can change that by clicking on this particle system type here, and change it to whatever you want. So what I want to show you for in this case is, for example, Steam 01. Okay, let's use the other Steam 01. Important to notice, these are all the different particle systems the game or any mod adds to the game. So these are all the available particle systems. You cannot specify custom particle systems, but you can essentially reuse already existing particle systems this way. So you can see this does some this emits some steam to the left here. So I want to rotate it here so it's present here to the top. And now we're going to talk about this active attribute over here. This active attribute here works different than from the active attribute in the world settings and camera. Those two use the same way of using the active this active attribute, but the active attribute of the particle system is a bit different. When it's activated, it just simply emits particles. When we deactivate it now, it stops emitting particles, but the old or the already emitted ones, they continue to do their thing. This then fully depends on whatever particle system type you have now selected. We're going to disable it and see it stopped, but the old ones still continue till they disappear. How this behaves now depends on the different particle systems. When I activate it again, some new particles get emitted. I want to show you this. It depends on what particle system it is. We're gonna change this now, not to this, but to NS Fireworks. This here is for Niagara effects fireworks. I'm gonna rotate this here up again. You just saw, okay, it emitted one particle, which was this fireworks particle, and now I want to re-fire it. I want to create a new fireworks here. So this happens when you go from disable to enable. So you can currently see it's enabled. When I disable now, nothing happens. But when I then change the state from disabled to enabled, this also works when you have animated it. When I now enable it, it emits a new firework rocket that explodes. So that means when I constantly turn it off and on and off again, I emit multiple fireworks this way. This depends on how the particle system works. As already mentioned, the world settings scene object is not a 3D object. So you can still drag it in and you can see it gets added, and when you drag it out it doesn't get added, but it doesn't get placed anywhere in the 3D world because it's not a 3D scene object. So that means you can also just click on it. It doesn't matter if you drag it in or just click on it. So when you click on it and when you add it, then you have now here world settings object. By default it's deactivated. Particle systems and cameras are by default activated, but world settings are not. When you activate that using this attribute, so that means you can change it over time if you want to. When you activate it, all gets dark. It's now midnight. We are at time of day 0. We can now change this time of day attribute here. This is an attribute, so you can animate it. When we now increase that value, you can see it gets lighter. It's now in the morning, and we are rotating the sun essentially. And this allows you to create some fake time-lapse animations, you could say, if you want to do that. But there is a small little problem. What if you have multiple world settings? So how does the system now decide what world settings should be used? So right now, okay, only this world setting is active with some noon time, I guess. And then there is also this other world setting which is currently deactivated, but with some midnight time value. So what happens if we activate that now? Nothing. So why did nothing happen? Well, the important thing is that the order inside of the scene object outliner matters. As mentioned, the camera and world settings active thing here work the same, because there can only be one camera currently being active. When you play an animation, there can be only one camera you're currently looking from. Same as for the world settings, there can only be one world settings object that currently manipulates the world's settings. And you can and this behavior, which of these is activated, depends first of all on if they are actually activated and on the order. So it's like from top to bottom, the topmost so like it goes from top to bottom, and the topmost scene object that is being activated, that has the most priority, and this will be the one that will be used. So right now you can see world settings and it is above world settings 1. Both are active. World settings is the topmost active world settings object, so these world settings will be used. If I deactivate this now, the topmost activated world settings will be world settings 1 instead. You can also rearrange the scene objects using the arrows that will appear when you hover over such a scene object in the scene object outliner. You can then say, okay, move it up one step, and now world settings 1 is on top of the normal world settings. If both are activated now, you can see the world settings 1 with the midnight time gets a higher priority because it's the topmost active world settings object. So this will be used instead. Only if this now gets deactivated, then the normal world settings here without a number will be used instead. When no scene objects are activated, it will use the time of day value from the previous, so like when it got firstly activated. So like it will then reset the time of day to the original time of day before any world settings have manipulated that value. The same as already mentioned is the case for cameras. The topmost camera that is activated will be used. If a camera is used, you can see the representation here will be green. If it's not being used, it will be red. So the topmost active camera right now is the normal camera here. And when I deactivate it, you can see now camera_1 will be used instead, because this guy here is the currently active one, or the topmost active camera. Now let's finally talk about attributes and keyframes. Attributes are values of some scene objects that can be animated. These attributes also have a so-called current value. Right now, this camera scene object here has a couple of attributes, but they are not being animated. They don't have any keyframes added. So when we move around that camera, it's just simply a stationary camera. When we now want to add a keyframe to all attributes of the selected scene object, so if you now select the camera and you want to now have all of the attributes have added a keyframe, you can press I. What does this mean that we have now here a keyframe? First of all, you can see a lot of different things turned orange here. These are called the keyframe controls. We will have a look at them later. For now, you can also see that this small little icon here also turned yellow. So a keyframe is essentially this specific change in time. So right now we said at the current frame 1, we want the camera to have exactly these values for the different attributes. We want it to have exactly the value 90 for the field of view. Okay, at this exact point in time. When we now say, okay, we want to change it over time, we want to now, like, after a couple of seconds, after a second of playing the animation, or like after 3 seconds of playing the animation or whatever, we want to now have a different value for the field of view. That means we have to set a new keyframe at that position. So we have to set a new keyframe for the field of view attribute. How do we do that? Well, first of all, we're gonna move to that new time point where we want to be. I'm gonna move now to the time point over here, which is now current frame 100, and I want to say, now, here, I want the field of view value to be not 90, but 30. You can see in the camera preview, we are now very close by. Right now, we only changed that value. So we only said, okay, this is now the current value that will be shown when we are here in the viewport. This is the current value that will be used to show here inside of the animation. So inside of the viewport. So it's not committed or anything. When we now change the current time, it will switch back to the old one. So right now, so this is why we have the current values. So you can now move around. You can actually check, does it actually look good if I change that value now? Because it doesn't have to. So if it does, I want to create a new keyframe. If it doesn't, well, I just continue on and go to a new keyframe, to a new current frame, to a different current frame. And when we do that now, you can see the field of view will reset to what the previous keyframe set. So previously we said it should be 90. It should be 90 degrees. So when we now move it, you can see it turned back to 90 degrees. But when we want to say, okay, we want to commit to those 30 frames per second, we want to say, yes, okay, at this, when we reach this point in time, this frame 100, then I want the field of view to be 30. When I want to do that, I have to say, then I have to create a new keyframe for the field of view attribute, because that's the attribute we currently care about. I want to now set a keyframe for this changed attribute. So how do we do that? When we now press I, we create a keyframe for all attributes of the selected keyframe of the selected scene object. Then all attributes you can see are now turned orange. That means now there is a keyframe. So now the question is, what should be the field of view value be between those two keyframes? So between this keyframe and this keyframe, what should be the value? This is defined by the interpolation. What this will exactly do, we will show you when we talk about the graph view. For now, you can see it just simply essentially creates a small little transition between those two keyframes, between those two values we have defined. This is now the interpolation, which is now like this zoom in effect. When we now move the time, when we now play the time, essentially, you can see it moves these keyframes, and you can see this is like a zoom effect. You can quickly step between keyframes using the comma and period keys. With these, you can quickly go through the different keyframes. For example, now add a new keyframe there, pressing I, and there, pressing I. You can now quickly switch here between the keyframes. Right now, we only have created keyframes for all attributes at once. But you don't have to do that. You can say, I only want to create a keyframe for one specific attribute or attribute group. For this, you have to use the keyframe controls. So go to this location here now. So you can see all of them are orange. When I now press I again, I essentially remove this keyframe for all attributes. So now I want to say instead for the position, I only want to create a keyframe for the field of view. So what I have to do is I have to click on this small little diamond shape over here, and then make it turn being a bright orange. With this we mean okay. With this we say okay, we now have a keyframe here. So this keyframe control can have different shapes depending on the keyframe type that is used at the when at the current frame, the point in time we're currently looking at, and this attribute has a keyframe, then the shape of this keyframe control can be different depending on what interpolation type that is stored inside a keyframe. Because a keyframe not only stores what value you want to have this attribute to be at this point in time, but also the different interpolation types to further specify how the interpolation should behave. For now, when this is a bright orange, this means the current value that is used for inside of this viewport here is exactly what the keyframe describes that is at this current frame. When we are at a point in time where no keyframe is specified, then we have this dark orange. This dark orange essentially means, we have keyframes for this attribute, so this value is animated, but and that means when you change, and that also means when you change that value here now to something else, and you don't do anything, and you don't create a keyframe, and you now move the current frame, also called scrubbing, when you now scrub the timeline, you change the current frame, this value will reset. Essentially a small little warning for you, if you want to view it that way. So if we don't focus on this field of view value, you can now see, it reset. But there is also there are two more states, and that is, for example, when this is a dark gray. Then this means this value doesn't have any attributes, and it doesn't have this attribute doesn't have any keyframes. So that means when you now change the value somehow, well, then it stays there because there are no keyframes, no stored values you could say you can define upon what this value should be at a specific point in time. This is not the case anymore. So this value is then simply static, and whatever you change here is now the value that will be used. So that is only the case when this here is dark gray, saying there are no keyframes for this attribute nowhere inside of the whole timeline. But there is still one more state such a keyframe control might have, and that is when you are at the current frame, the current point in time, you already have added a keyframe for a given attribute, but the current value is purple. This will tell you, hold on, you are at a keyframe right now, but this keyframe has a different value of what you're actually looking at inside of your viewport here. That means you can now either like overwrite the old keyframe, or when you change the current frame, you scrub the timeline, then, well, then it resets that value. When you go back, you can see now it's orange again, because that's the exact value we said this keyframe should have. You may have already seen, interact with those keyframes a little bit more. So when a keyframe is this dark orange, meaning, well, there is no keyframe yet at the current frame for this attribute, and you just make a single click, that means you're gonna add the keyframe you add a keyframe for the current point in time with the current value. You can now remove that keyframe by clicking on that orange icon again. So if there is now a current value, if there is a keyframe at the current frame or point in time, and it has the exact same, and that keyframe has the exact same value as the current value, then this will be orange, because there is essentially no change. And when you click on the keyframe control now, you essentially remove that keyframe. When it is purple, that means you have a keyframe at the current frame, e.g. point in time, and the current value of the attribute, so what you're using to look at to be shown in the viewport, is different from what the keyframe dictates. When you now click on the keyframe control, you essentially override the old keyframe with the keyframe with the current value. So the value you're currently using in the viewport, this value will be used now instead. Ta-da! Just like that. There is one more interaction you can do, and that is doing a double click on a keyframe control, and with that you're essentially removing all the keyframes from that attribute. Also to note is when there is just one keyframe, if there's just one attribute that has a keyframe at the current point in time, and you press I, by default you can change that when you press I to create now a keyframe for all attributes, then it will simply override that, and all the other attributes here now will also get an attribute at the current point in time. So if you press I, you can see all attributes turn orange. If I press it again, as said, you remove all keyframes. And if it's the case that all attributes have a keyframe at the current point in time, but at least one of the attributes current value is different from that keyframe, like it is purple and it means that the attribute has a changed value, and you press I, you then override this attribute with the new current value, storing and committing this current value now as the correct one that should be used for this point in time, essentially. And not removing all of them. No, you're just overriding them. So that means you can only remove all keyframes if all keyframes are actually orange, and means the keyframes, they don't deviate from the current values. And if that's the case for all attributes, only then you can do that. Now let's talk about attribute groups. Attribute groups allow you to just simply control, make the control, and using these keyframe controllers a little bit more easier. For example, you want to say, okay, you only want to store all the create now keyframes for all the different for all position coordinates, because like you have like X, Y, and Z. And if you say, okay, you want to now store for the whole position, now the keyframes, you would have to do that for X, Y, and Z separately. This is a bit annoying. So what you can do instead is you can use the position attribute over here. So if you want to say, okay, for all these position coordinates, I want to create now a keyframe, you can use this position keyframe control instead. And you can see I just clicked on the position to create a keyframe for that position, and this essentially tells X, Y, and Z attributes, those three different attributes, to now do this set keyframe operation essentially. This also works for rotation. And there is even one more bigger group for the whole scene object. So this group contains all attributes of the scene object, and this can be used can be found in the scene object outliner down over here. There's also a small little keyframe control that allows you to change the whole interact with all attributes of all the attributes of that scene object to change the different types. When you have already set a keyframe at the current point in time, the current frame, for a given attribute, you can also do one more interaction, and that is right click on it, and that allows you to change the interpolation type this keyframe will use. What this means I will show you in a second. So now we're gonna create a simple animation. Later on we are gonna make a more fancy animation. So this simple animation we're gonna use to explain some different concepts here. So we have this camera now here. I selected it and I'm gonna press I now because I want to have a keyframe for all the different attributes, and I'm at the current frame 1, essentially at the start of the animation. So now I'm gonna change the current frame, current point in time, the current frame, to the end of the animation. I move the camera to a new location, for example, like this, and I'm gonna say I want to make a new keyframe here, and you can see now there is a blue line here in between because that means our camera changed from the position from here at the beginning of the animation to the position over there at the end of the animation. Everything in between will now be interpolated. So that means if we change now if we now scrub the timeline here, you can see how it appears as if the camera would be animated and would move. Especially this way of creating a camera animation using the camera preview, this gizmo here to move things around, it's very practical to also use the auto keyframe feature. In the editor settings panel, there is this auto keyframe box which you can enable. When you have this enabled and you now move if you now move like the camera around or change the current value of a given attribute, it will then automatically create a keyframe for all attributes of that scene object, all of the selected scene objects. So make sure it's the selected scene object that will be considered for this auto keyframe option here. So I have now this camera selected, auto keyframe is activated, and I now move the camera around. I change the current value, not based on a timeline scrub, but because I manually said, okay, I want to move this now to a different position, then it will automatically create a keyframe for me. So you can see it directly turned yellow, meaning, okay, there is now a keyframe. And also the attributes over here are now pretty much all orange because now I have a new keyframe. There may be a bit of purple due to some floating point round problems. That is some normal this is some normal computer related troubles, but for now you can see I can move it around and it essentially stores that keyframe there. And you can now go to a different point in time and do the same exact thing, and it will automatically, without the need of pressing I or whatever to say, okay, I want to have now a keyframe there, it automatically creates a keyframe. So this is it can get annoying if you forget that you have this option, activated, but it's very useful for creating the first set of an animation, the rough animation of a camera. You can, when you use this auto keyframe, it allows you to create the first rough definition of how you want to animate it, and when you then later on want to specify it in more detail, I recommend you to disable this auto keyframe feature. At this point, I also may want to note that you can use your mouse wheel to scrub the tunnel, change the current frame here. You can also hold shift to make that a bit faster. You can also use the left and right arrow keys to do the same. At this point, I also just wanted to mention that you also can move the camera with one or the 3D scene objects with one more additional way. That is using Control G. You can then move the camera around on the plane of the viewport, essentially here. creates a plane here, and you can move the camera here around. But you can also lock it to the local to the axis. So like for example here, I'm gonna lock it to the x-axis. I can also lock it to the y-axis. I can also lock it to the z-axis. And when you don't want that, you can press escape, and it stops doing that. So it doesn't use that new location. You can press escape, it doesn't use it. Or what you can also do is, if you want to use it, you then have to essentially just simply press the right mouse button, and you then have to, the left mouse button, and it then uses this position. There is also one more way to change the current frame, or the time, the time of the current point in time, and this can be done by clicking on such a camera path here. You can see there is a bit of green there, and that is essentially where I'm clicking onto this camera path. When I now click, you can see we jump to the current frame, which would be used when the camera would be at this exact location. So if the camera is at this location, we would use this. We would be at this current point of time. So this, you can change this here and just define, oh okay, I want to make this camera path look a bit different. So I want to say, okay, this moves a bit down, so I'm gonna click over there and then move the camera down, and I'm done with editing this way. So this interacting with the camera path here also allows you to change the current point in time. So now let's finally talk about the graph view and the different interpolation types. As I already mentioned, the graph view is this large window with these with this grid and this colorful lines here down here in the timeline. First of all, this is essentially a time value diagram. So from left to right on the x-axis, essentially, you can find the time progressing from left to right, 1 till 300 in our case right now. You can also see this highlighted area. Just as for the frame selector, this dark area means this is outside of the animation. The highlighted area means this is inside of the animation. And this dark area here, again, outside of the animation. That means here's the start of the animation, and here's the end of the animation. You can now pan around this view. So like up and down here is, by the way, the value axis. Like up is like plus infinity, down below is minus infinity. And you can pan around this graph by somewhere on the graph here, then click and hold the right mouse button, and you can then pan the graph around. You can also hold Control and then use the mouse wheel to zoom in on the time and the value axes. You can also hold Shift to only zoom on the time axis. And you can also hold Alt to only zoom on the value axis. When you messed up for something like that and you want to view the whole animation, all the value changes, you can then right click and then click Fit All. So these colorful lines here, or white lines, depending on what you have enabled. So you can change what you want to view. For example, red is here X or pitch, green is Y or yaw, and blue is Z or roll of the position and rotation. You can directly see here this color coding. And you can enable what attributes you want to have been represented here. You can also say that you can use the whole groups here. You can use, say, okay, you want to hold the whole scene object. When there are more scene objects, you can see we now also have the other scene object down there. You can enable them however you want, what you want to view. It doesn't matter. And you can also, like, say nothing. Pretty useless. But you can also say you just want to have one attribute of for example, the position. Like in our case, I want to have a look at the Z attribute. You can then directly see here, okay, so this essentially represents the change of the value of the attribute over time. So you can see like here, the value star begins at this point here, and then it increases, which is here on top, and then it decreases again, goes down here, and then slowly increase, like it decreases here, and then after this keyframe here, it slowly increases. These orange points here are then essentially the keyframes we already have created. The orange bar here just simply represents the current frame, the current point in time of which you are looking at in the viewport. You can also click on that on such a graph here to create a new keyframe at this very location. You can also use the left mouse button to create a selection box and select different keyframes however you want. So you can see they, from dark orange, they then go into a light orange to say they are now selected. You can also use the modifier keys to say, okay, you just want to add new keyframes to the whole selection, remove just keys from the selection when you use the selection box, stuff like that. Inside of the graph view, you can also select different keyframes and then drag them around to just simply reposition them or change. You can see, like, I can change the value of the keyframe. In this case, we are changing the height, so you can see how I change the z-axis, the height. I can also change the position in the time, and you can see I move that around. You can also use shift to lock to one specific thing, like for example the modifier keys, like shift allows me to move them up and down, control allows me to move them just left and right, for example. So now let's finally talk about the interpolation types. Right now, the default interpolation type is the Ease-Interpolation. You can see how the attribute here is, how this behaves very smoothly. So like we are, when we change the camera here, so like we are moving up, but then we move up slower, so we don't move anywhere in regards of the height. So we're only focusing on like the up and down movement. But then we slowly begin to descend, then we descend quickly, and then we slow down our descent again till we don't slow down descent anymore. Now we're just simply moving up a little bit. So we can see we don't have any hard velocity changes. We don't change the direction of movement hard or quickly. No, it's everything smooth out. This is thanks to the default interpolation called Ease. This is technically called Bezier spline interpolation, and you can do a little bit more than that. You can even specify a little bit more how this curvature here should look like. So now let's finally change the interpolation type. So in the graph view, you can change the interpolation type by simply selecting a group, or if you don't have any selection, just right-click one of these attributes, then you can change it with this context menu. Or you can also do that with the current at the current frame when there is a keyframe for the attribute you care about. You can then just simply right-click the keyframe control over there, and then you get the same context menu. Then can change the step. When you have it in a graph view, select multiple different keyframes, you can change this as a whole, and then the keyframe controls over here, you can change it for the whole groups, like here in the case position and rotation, or even all attributes. So now we're gonna have a look at the step interpolation. So we just look at the Z attribute here now. You can see we're gonna, after this step interpolation attribute, we are staying at this exact value of the attribute till the next keyframe. Then we directly jump to the new value. You can directly see here now this red arrow, this red line, this camera path here is actually the blue dots here. Essentially, those are the normal interpolated frames, and the yellow ones are the keyframes. and this red line connects these different frames together, so you can actually have a more in-depth look on how the actual camera moves around, especially when you have multiple camera paths close to each other. You may notice the slight slope here. This is just because this line draw goes from this frame to this frame directly and doesn't consider the space in between. But so this may look like when you're playing it that it then uses this linear stuff in between, because when you just use the play command, as said, we're gonna go. We try to render at the settings you have given the game, or the as many frames per second. So we actually may render visually the frames in between two frames of FicsIt-Cam here. But the interpolation type still considers this, and the jump only happens when you're at least exactly at that new keyframe. Only then we use the new value. So even if it's in between those two frames here, it won't use the new value only till it exactly reaches this point. Then it uses the new value. So this is your step to essentially just allow jump cuts. And as you can see, instead of jumping from this position directly to this position, this would happen if all our position attributes would use step interpolation. No, we only say it only jumps in regards of the Z coordinate. So the other two normally use the Ease-Interpolation right now, but the height, the Z position, that uses this jump keyframe here. Now let's have a look at the next interpolation type, which will be the linear interpolation type. So if you change the interpolation type now to linear, you can see this also the icons change. You can see that in the Keyframe Control, also in the graph view down here. So linear is now this X, and step was this rectangle, the square, and Ease-Interpolation is this diamond shape. So in this linear interpolation, we essentially have a constant change. So like we don't have any acceleration happening, so like we're not slowing down or speeding up. No, we have a constant change. We have a constant velocity in the movement. It goes straight from one keyframe to the other. No curvatures, nothing. So that means no changes in speed. We have a constant speed descending here. The next interpolation type which we want to have a look at is now ease and ease in out. Ease in out is very similar to the ease interpolation. So for now, let's just have a look at the ease interpolation, and you can see we now have this nice little curvature here. This is now a nice interpolation, and when you select such a keyframe, you can see these handles. These handles are the handles for the Bezier interpolations, for the spline. So a spline is essentially the section between two keyframes, and this spline here is now considered for the ease interpolation. So this is why we also see this handle over here. So you can now click on the handle and change it as you want. And you can see we are changing the curvature, the interpolation curvature here, however we want. We can give it full control. We can here fully change how it should be shaped as we want to. And the nice thing about that is we have now full control essentially over how this whole thing should behave. But we can now you can now see like after we have our keyframes. This here is the actual maximum value we have ever given someplace in regards of keyframes. But our animation actually continues to go up. And then we have a maximum value of like over here or whatever. And this is like not... this is only the case when you actually want that. But sometimes you don't want that. So this changing this handle is especially useful when you transition to a new keyframe type. So for example, if we change this here now to linear, you can then say, okay, we are like moving here linear down, and we are making a sudden change, like we are going in here and then we suddenly move down. If you don't want that, you can then use these handles to then change that so you're actually like approaching it a little bit better. So here we actually are now, so at the end of the Ease-Interpolation here, we have the same velocity in the Z direction here as we would then have in the linear down there, so that we can do the same down here. So we're going to rotate that here so that we simply slowly end this linear interpolation step here. So changing these handles is for the Ease-Interpolation is very useful when you're working with other interpolation types, especially this linear interpolation type in this case. So, but if you don't want that anymore, if you want to have the best like use, because like by default this is not the case, this is now custom Ease-Interpolation. It's not an option because it only happens when you then actually change the handles. But if you actually want that, if you don't want that, if you want to have the automatic handles, because like FicsIt-Cam will try to calculate the handles automatically to make the best smoothest path so that it doesn't shoot over, as I would call it. So like, since we are now here like even higher than the highest keyframe we have, so that this overshoot doesn't happen, you have to take it to take the handle to be horizontally, and there is and like FicsIt-Cam in the normal ease mode calculates these handles for you. So if we now change, if we want to reset that now so that it calculates these handles automatically again, you just simply change the type. Oh, not good. You change the type again, just simply to linear. You can change the type back to ease. So when you have it here, you can now see when I move this keyframe around how the handle here actually changes now. Because I moved this keyframe here around. Yeah, okay, you cannot see it because it's not selected, so you cannot see the handles anymore. But when I move it around, you can see how the handles of this guy here change. So you can. Oh, wait. Okay, hold on. We're gonna have to make it easy because it always also changed. So now you can see it now uses the automatic way of defining the handles. And you can see how the handles here rotate and try to calculate for you the best setting for the handles to make the smoothest possible and most sensical interpolation, essentially. So this only happens when you have this. So when you have a keyframe like this in between, but you don't want that, you want to say like it should slow down, reach that keyframe, and after that continue the speed up again or whatever. If you want something like that, then you can use these in out. This essentially makes the handles horizontal. Like that. And you can see we also have a different icon now. So now it's also probably worth mentioning that FicsIt-Cam here inside of the editor has a undo and redo system, or called a transaction system. And you can use this by pressing Ctrl Z and Y. So this applies to all the different changes you can do in this graph here, moving the keyframe handles around, moving the keyframes around, changing the keyframe types, but also interacting here in the 3D world using the auto keyframe feature to move them around, pressing I to create a keyframe set, or also creating and removing new scene objects. All of this stuff uses the transaction system, allowing you to undo and redo these different things. You can see I press now Ctrl Z over and over again, and I'm slowly undoing and redoing now, and now redoing the things again, and change that. So now let's try to create a camera animation like in a more proper way. So there are two ways to do that. So the first one is like using the autograph keyframe and not being locked to the viewport camera, so like looking at the camera from outside. First of all, making sure it's gonna be active, because we only have one camera here right now. I want to make it active, and when I want to create now the camera animation, gonna start at a specific location, make sure that it is activated here. Then I simply move it around via the gizmo or this grab tool here. This fully depends on what you want to do. I gotta position it now over here, and I go to the new point in time where I want to create the animation. Then I move the camera to that new location, something like over there. And then go to the next point in time and move the camera to that location where I want it to be there. Maybe I want to edit now in between, so I'll go back in time here. And I'm gonna move it down. And then we're good. And now, okay, I maybe want to go like to this point here. And maybe it would be better if I position the camera a bit down. So so I may want that, maybe I don't. So let's just deactivate auto keyframe. I'm gonna move it down. You can see you can also toggle this also with a shortcut by pressing K. So I'm gonna move it down. Okay, this is not really what I want. So, but there is also a different point where I maybe want that. Maybe over here I want to move it up. Yeah, that seems right. So I'm gonna commit that. So I can see that it seems right because I have this small little preview over here. So this is like one of the ways to change to like create an animation using from the outside, then using the gizmo, and also using this tool if you want to define how the camera should look like. This is especially useful when you also use other scene objects like particle systems and whatnot, or want to animate those. Especially when you use particle systems and want to animate the position of a particle system, then this is the only real way you can animate them, using the gizmos and stuff. But specifically for a camera, you can also use a different way to animate. Essentially, use a different way to animate them, or a different workflow. So in this mode, I also again make sure that I select my camera because I want to still use the auto keyframe. Enable auto keyframe, and I'm gonna disable the camera preview because we are seeing the same thing as the camera preview, so we don't need the camera preview. So, and in this way here for now creating a camera path, this is very useful when you want to make a cinematic camera shot, for example. I would say go to a position. So I'm using auto keyframe right now, so I go to a given position, go to the next point in time, moving it around to the new location, something like that, I guess. I'm gonna move to the next location, which is over there. And now I, for example, want to have move a little bit forward, but now I want to do a little bit of a zoom effect. So I'm gonna move in here. And I'm gonna have this now. So if I go now through the animation here, you can see it's a bit of blue. This is a bit annoying. So now this is something I haven't said yet, I think. When you look at the camera from outside, and you can see this camera path. Now you can also see the red lines here. And the camera, if you don't want to view that, this is especially useful when you are like in this mode, and you don't want to see the camera here constantly. You can disable this by using the show camera path here. And you can disable that, and you can still animate here just as you want to. So you can see we're now here. We would be zoom in. Right now I'm playing backwards, so I'm zooming out. And here we're gonna have some camera animation happening, just as we have defined. Oh, there you can see. That's not ideal. We're flying through a tree. There are multiple different ways. So either I'm gonna replace this keyframe or this keyframe, so I can switch between those with period, with comma and period. This also works in the other way to edit a camera, edit a simple camera fly animation. Doesn't matter. You can switch between those keyframes here this way. So either you reposition those a bit. So for example, I'm gonna deactivate the auto keyframe because maybe I don't want that. So I can fly around, and I want to say, okay, I'm gonna go a little bit more over there then. And I'm gonna say, okay, and I'm gonna commit to that. So I'm gonna pressing I. So you can see a little bit of movement that was in the graph view. So maybe it works now a little bit better. Are we now colliding with the tree? No, we are not colliding with the tree. I'm still a bit close to the tree maybe, so maybe we want to realign that. So I'm gonna go to that position. I'm gonna move a little bit away. I don't have an auto keyframe enabled, so I'm gonna have to do the keyframe manually. So I'm gonna press I, and now we have here this new movement. And look at that. Yeah, so now we're a little bit close to the bush, so let's move a little bit over there. Gonna do the keyframe, and here we go. And now we are zooming in again, and now we have a small little camera animation here. So if we want to replay it, also works in the other ways, in the other option obviously. Let's just hit the play, and now we can essentially look at how it would look like in normal play speed. It's a 10-second animation, and we're zooming in, and done. So yeah, this is our animation we have to find now, quickly and easily. So now we have edited a simple camera animation, and now we would want to play it in game pretty quickly once to have a cool live preview here, especially useful for live streams and stuff when you want to create a beautiful cinematic camera shot of something, or you want to render it as an animation, like creating a beautiful cinematic scenery shot of a large factory that would run with like 20 FPS or whatever, but you still want to create a 60 FPS animation. Then we want to use the render command. So for that, first of all, we're gonna have to exit out of our animation, of our editor. And here we now have to do the play and render. To now finally play a camera animation inside of the game right away here, so you can record it with OBS, or this is especially useful when you want to do a live stream or whatever, because then you cannot take some more time to create the video. It has to be presented live, so then you want to play it in real time, the animation. For this you want to use the FicsIt-Play command, which allows you to exactly do that and play a scene or animation in real time directly inside of the game here, without any other things. You can also provide a fourth argument here, which is true, to run it in background, but we will not have a look at this for now. We will have a look at this later. So we just want to play the scene right away and essentially in foreground. So that means our character cannot move anymore by itself. Instead, we are fully focusing on having a look at the animation. So we're going to type FicsIt-Play and then our scene name, which is test. So now you can see it's playing in not 30 FPS but more, and you can stop animation using C. When you press C, you can stop this animation from further playing. You can now also use the FicsIt render command to render an animation. This essentially means for each frame, so this now fully depends on your frame rate you set with the FPS, you can now create for each frame an image file with the given resolution you have defined in the scene settings to be stored on your physical drive. With this, you also can make sure you don't have any lag. FicsIt-Cam, when using the render command, FicsIt-Cam will essentially slow down the whole game so your GPU and CPUs are able to fully create the frames for each of the frames you want. So when you say your factory, when you should play your factory, your game only runs with 20 FPS, okay? And you are now wanting to create a cinematic camera shot with 60 FPS. You just simply tell in the scene you want to have it in 60 FPS. You want it, you have a given resolution. You can even type in 4K if you want to. And you then want to, when you then render it, the game will essentially run slower as a whole. It will then take the images. But when you then later on process these images, slap them together to one video file with like 60 FPS, then you have a smooth experience because like the whole animation slowed down for you to make sure that whatever is then taken as an image sequence is then captured with the proper speed. So that means using the render command, you can create, even in a save that runs with just 20 FPS, you are able to create cinematic camera shots with like 60 FPS if you want to. So for this, you're gonna type FIC render, very similar to the play command, and then again the scene name you want to render. So we're gonna render now our scene, which is called test. When we now run this, you can see as a whole it's running slower and it's a bit more stuttery because we're only running in the 30 FPS right now. We can also cancel it just like in a play. And now the images will be stored. So now in your real hard file system, there's now created a couple of JPEG files numbered with the frame that the image was taken and with the given resolution set in the scene. You can edit now. Such image sequences are not just used when we use the render command, these are also used for the time-lapse cameras. When you're using a time-lapse camera, the only difference then is that there is additionally, before each frame number JPEG, there is also a prefix with the timestamp of when you have started the time-lapse camera. These image sequences are located in your file system under the local app data variable /factory game /saved/save games / a new folder called FicsIt-Cam. And in this folder there are now folders for all the different all the different scenes with the name of that scene. So we had rendered now the scene called test, so there is now a test folder. Inside of this folder you can now find image sequence, a couple of JPEG images with the given resolution we defined, and they are numbered through. And these images now is essentially a render of our animation. Most video editing software is capable of reading such an image sequence right away. Just dragging in the first image of that sequence into the video editor often already makes it to recognize this whole as one video file essentially. If that is not the case, you can still render them via a different tool into one image file. I, for example, recommend to use FFmpeg, which is also used by OBS. You can install a CLI for this, so just simply Google around for that a little bit. And then you can use a command like FFmpeg here to create this output MP4 video file based on the image sequence. For that, I'm gonna define an input with a %d to say, okay, this is a decimal number now, and I have the .jpeg ending. And I want to create this this video file should have a frame rate of 30 FPS, because that's also what I have defined in our scene. When I now run this command, you can see this slowly converts now our image files into one video file. And this video file is now located all the way down here with is called output MP4. And as you can see here, we can play it just normally. As already mentioned, FicsIt-Cam also adds a couple of other camera management tools and utilities. For example, time-lapse cameras. Time-lapse cameras are cameras you can either position somewhere stationary or animate them using scenes in the background, scene player, that will then take images in form of an image sequence, just like the render command, but with way more time in between. Like here we are talking about seconds per frame and not about frames per second. So to create a new time-lapse camera, you're going to use the FIC command, and then there is a sub-command called Timelapse where all the time-lapse camera stuff lives. And now we want to create a new time-lapse camera. Every time in the if you see in these syntax messages camera argument, this can mean a simple name or a camera reference. What a camera reference is, we will have a look at later on. For now, we want to create a stationary camera, not wanting to use a camera reference, and we're gonna call it MEEP. We want to take now 1 frame every 2 seconds. You can also see as float, so you could also use 2.5 seconds. So we want to create a time-lapse camera called MEEP every 2 seconds. When you use just a name instead of a camera reference, then the time-lapse camera or camera feeds will use the same settings as you are right now. So that means like resolution, field of view, also the position and location, and rotation. All of that, what you're currently, like essentially how you are currently looking into the game. This will then be used for the time-lapse camera or for the camera feed when you're just using a name like MEEP in this case. So if we're gonna run this command now, you can see time-lapse for MEEP created. Important to notice, we have not started, so it doesn't create any image files now. To start the time-lapse camera, we're gonna use the time-lapse submenus essentially. Time-lapse then the sub command start to start camera. So then we have to provide time-lapse camera or the reference again, which we just called MEEP, to then start the time-lapse camera. If we do so, it will then store the timestamp of when we have started this time-lapse now. So now it takes 1 image file every 2 seconds essentially, and stores it as an image sequence at this pretty much the same location as for the render command. Though, as already mentioned, the image files will have a prefix of that timestamp we just it just stored when you typed in the start command. When you now save the game, close the game, boot up the game, and load the save file again, it will continue the time lapse. I think with a new timestamp, though I'm not quite sure about that. But it will then directly continue again. This may not be good, since the camera will now constantly take new image files and will clutter your file system. So to stop a time-lapse camera, you're gonna use the FIC time-lapse stop command and then provide the name or the camera reference again to then stop the time-lapse camera. Very important to note is you don't have deleted the time-lapse camera. It still has stored the settings from previously when you created it and looking at the same direction and whatnot. And you can still now start it up again. It just gets a new time-lapse, new timestamp, but you can start the time-lapse camera with the exact same settings. This is especially useful when you have one setup that you reuse over and over again and want to reuse the time-lapse camera also between save files, essentially, not save files, but like save sessions, or you have one giant project which you continue at some point or not, and you don't want to constantly clear your file system with image files. With this, you can essentially also pause to take a time lapse, so you can focus on a different part of your factory, for example. To remove a time-lapse camera, you're going to use the FIC time-lapse delete command and then provide the camera name. So now let's have a look at the next big feature of FicsIt-Cam, which are additional camera feeds. Essentially, additional windows that are a small little window into the world, into the Satisfactory world, just from a different angle, essentially. You can do this by creating, first of all, a new camera feed, and everything you have to do for the feeds is using the feed sub command here. So with FIC feed, you can then see we have a couple of sub commands: create, delete, start, and stop. To create a feed, we're gonna use feed create, and then again you can use name. It works. This camera argument here works exactly the same as a time-lapse camera, so means a normal name, just a name. The same naming rules as for scenes apply here. You can use a name instead, and then uses the same settings like resolution and whatnot of your current scene. to create then the feed, to define the feed, or you can use a camera reference instead. So for now, we're gonna call it Meep. We're gonna create the new feed here called Meep, and you can see feed for Meep created. Next up is we're gonna want to start it up, so we're gonna say feed start and then Meep, and when we hit enter, you can see a new window appears. You may have noticed this window is rather large because, like I said, it takes the same resolution, and that means like you now render the game twice with the same resolution. This is quite GPU intense. So especially for feeds, it's very recommended to use a camera reference instead, because it also allows you to change the feed's resolution. Though this takes less performance than as if you would run two times the same game and then use multiplayer, some local multiplayer setup instead, because the game only stores all the objects, location and whatnot just once. So especially in regards of memory and some other and a lot of other processes, this is only happening once. It's just that there is a second render pass essentially for this window over here. There's just a second render pass for this window here. Also to note is that this window is called Meep, so this is exactly the same name as our camera feed. And if you use a camera reference, it uses then the camera reference instead. So this is especially useful for like using OBS and stuff, because you can always then reference this window by the title, because the title this title doesn't change. It's exactly the same as the feed you have created. Now you can see I can move the other viewport, the actual game, separately from our camera feed, and I can move it even in front of the feed, and I can now see everything that is happening here just on the second camera feed here. You can create multiple camera feeds at the same time to have essentially multiple angles at the same stuff that is happening right now. You can close this camera feed or stop this camera feed either by simply closing the window here in Windows, or you can just simply run the FIC feed stop command. Important to note is we have now changed the position of the window and stuff. And we don't have removed the feed. So the feed, just as for the time-lapse camera, still looks at the same location and whatnot. It has the same rotation, blah, 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 all that sort of stuff. But it also has now persisted the window's location, position, and stuff like that. So that means when we now start the same feed again, we haven't removed it now, so we just start the previously stopped one. This is also saved between save sessions, so like you can save the game, close the game, boot up the game, load the save file again, and then it still persists this information. It still uses this old information. So if you then say FIC feed start Meep, you can see the window appears exactly at the same location where we previously were. When we first created this window, it was like all over the screen. I then moved the window down there, closed the feed, now started the feed again, and now it stays at there where it previously was. This is especially useful when you have a neat live stream setup. It still persists the window location, so you don't have to mess around with it all of the time. To remove a feed, you can use the FIC delete command. So you don't have to stop it. If you just use the delete directly, it directly stops the feed also. So you can use the feed delete command to delete that feed. So FIC feed delete Meep to delete the Meep to delete the feed called Meep. Enter, and it says feed for Meep deleted. Okay, so I took the test scene we previously created and changed it a little bit. So we have now two cameras, camera 1 here and camera 2 over there with a more top-down view. And this first camera here is also animated in regards of location. And it also then, like at frame 150, now like disables so that the other camera is the currently active one. Okay, So this is very important now when we talk about the camera references, that first of all, the active camera changes. This is very important. And that this camera down here moves. Okay? So these two things are very important to now to understand. So when we talk about the camera reference, so they actually understand what is actually happening here. To now understand how camera references work, we're gonna use a couple of camera feeds. You start a camera reference with a hashtag usually, and then you're gonna have to provide a scene name. In our case, it's the test scene. If you type this out, this essentially means that at frame 0, we want to ask the scene called test, what is the active camera? And then we ask this active camera, what is its location, rotation, or camera settings? I'm gonna call this from now on camera settings when we talk about like the camera's rotation, location, field of view, aperture, stuff like that. So we're gonna then ask this active camera what its camera settings is. And this will then be used for the camera feed. Even when you then edit the scene, and then start the feed afterwards, it now uses the new information after you have added the scene. So you're constantly just referencing that. It never, when you create the feed, it doesn't copy that information, it just references it. So even if it changes, you still then use this new changed information. So we're gonna run this now, and we're gonna start that feed. You can see, very small because I have decreased the frame rate. We are using actually the rotation and location of that. It's like this is just 100 by 100. We are now using the location and rotation, the camera settings of the camera feed that was activated previously. It's like the first camera, the camera 1. We can change the frame of consideration. As mentioned, right now we are asking at frame 0. This is actually not true. We are asking at the beginning of the animation what the active camera is. Now we're gonna say, okay, we want a specific frame to be used. We want to say we care about the active camera at frame 200. So for this we're gonna say we type the hashtag, then 100, then we're gonna type tilde, and then the scene name. So for this we say, okay, we then so like the camera feed will now constantly ask the scene, hey, scene called test, what is your active camera at frame 200? And give me the camera settings of that camera at frame 200. If we do this now for frame 200, and we're gonna create that feed now, you can see it uses this top-down view, the top-down camera instead. So like the camera 2. As already mentioned, it not just takes in consideration the currently active, the active camera at that given frame. No, it also considers the position of this camera. So if we're gonna have a look at frame 140, where still camera 1 is the active frame, the active camera in the test scene, and we're gonna create a feed for that, you can see compared to down here, we are now at a different location. This is the location and rotation of the camera 1, the active camera, but at frame 140. So we now had a look at, you can reference a scene directly and then use the active camera of at the beginning of the animation, but we can also define what frame we actually care about. And you can also now specify the camera directly which we want. So it now so you can now define what camera you want instead of using the active camera at a given position. For this, after you have typed the scene name, you can then type colon and then provide the camera name. So for example, in our case, camera 1, this will be indifferent from the hashtag test camera feed we already created. So let's say camera 2. So this will now take camera 2. It will now show always camera 2, even at position 0. So if we're gonna create so if we're gonna create this feed now, so you can see, even though we are technically at frame 0, I haven't animated camera 2, it still uses camera 2 instead. So it ignores the active camera and goes directly for the specified one, which is camera 2, and takes its camera settings at frame 0. So you can also define this, you can still use the frame numbers to actually then define at which frame you want to take the camera settings from. So if we're gonna create now a feed, for example, for frame 200, where we now know, okay, camera 2 is the active one in this test scene, but we say, okay, we want to focus on camera 1. Okay, so we now create a feed always for camera 1, but it uses now the camera settings at frame 200 and not 0 or whatever. So if we're gonna have a look at this feed now, you can now see, even though we are in frame 200 and actually camera 2 would be the active camera, we are still looking from camera 1, but the camera's position, location, the location and rotation and field of view values and stuff like that are taken from frame 200. And we can even take that one step further up and animate these camera feeds. For this, we need the background player. I will show you this in a second. First, I'm gonna have to tell you, using the hashtag means it doesn't consider these background players. So that means it always uses these cameras here, and that means these kinds of camera feeds won't be able to be animated. This can be useful if you want to reference the same exact camera or the same scene or whatever, and you want to have one feed that is animated and one that is not animated. Can be the case. So with this, you can then specify this a bit more in detail. But if you want to have that feed animated, then instead of using a hashtag, you're gonna use the bigger than symbol. So using this bigger than symbol means, so now you can still use a reference like the frame with the tilde and one specific camera. And it will then use this. But important to note is that for so like everything works then the same, though the frame number you provide, when you provide one, or if you don't provide one, then it also always the frame number always defaults to the animation start. But this frame number will be ignored if there is a scene playing. Okay? So when you use this bigger than symbol. So if there is if the test scene is indeed playing somewhere, either in foreground or background, it then ignores this frame value and uses the frame value of the playing scene. Okay? The camera setting still applies there, so you can say, okay, I want to use the active frame, or I want to use the active camera, or I want to use the specific camera. This doesn't matter here if it's an animated camera feed or not. But if it is a animated camera feed, or this also applies for time-lapse-camera, so it's just this construct of the camera reference here. But if there is not currently a playing scene, then it uses this frame setting here. And if there is a currently playing scene, then it uses the the time value of that playing scene. So if we're gonna type this now, and we're gonna create a feed for this. So now you can see how this here is indifferent from our hashtag test camera feed over there. But when we now play our animation, so we're gonna say FIC play, and then we're gonna play our scene, you will see that the lower one, this here, the hashtag test, will stay stationary and be the same as it would be at the beginning of the animation, but the upper one will be animated. So if we're gonna play this now, you can see the upper one plays, and now even it changes the active frame because we haven't specified a specific camera we want to have a look at. It uses always the active camera then and updates that and is essentially animated, while the lower stayed stationary. So the neat thing about these camera feeds is that they can show something different from what you are actually looking at the game. Inside of the game right now. But when you want to animate this camera feeds, what we have done so far with the normal play, we have seen this was not the case. It was always the same. So that renders this feature pretty much useless. But you can play an animation in background. And camera feeds will consider these rendering in background animations. So for this, you're gonna type FIC play and then your scene, and now you can type true to say, okay, we want to play this now in background. It won't play right away. It will now create a background scene player. This background scene player can be started and stopped or paused. Can be started and paused, and you can also stop it. And when you stop a camera scene player, this is the same as when you would then remove the scene player. Important to notice that you cannot edit currently. If there is a scene player, you cannot edit the scene, and you cannot play the scene then in foreground. You can only do one of. You can only want to say like have a background player that is either running or not, but if it matters if it exists. So either a background player for a given scene exists, or you play it in foreground, or you are in edit. Only those options are possible. So when you are now, now we essentially created a background player for that scene, but it's not running right now. So now we actually want to start this background player so that the camera feed is animated. For this, we're gonna type in FIC start and then the scene name once more, start test. And you can see it plays in background. We can even pause that using the pause command. You can see it halted. It stays at the location, but the animation, the scene player animation essentially just halted at place. You can continue it using the start but you then can continue the animation again, the background playing scene using the start command once more, and it continued where it left off. You can then remove a scene player using the stop command to remove this background scene player. And now that means you can now again play it in foreground or go into the editor. For solo live streamers, it could be a bit annoying to constantly have to reinitiate such background playing scene player, such a background playing animation. So to counteract that, you have to either use a very long animation or you use the looping option of the scenes. Because as mentioned, if you enable this, it will play over and over again. And I have created here a meep animation that will pan around one point from left to right and has a seeming transition between start and end. And when I now use this background player for this, you can see the camera feed constantly panning around this point, this point here in the 3D space in the camera feed, while I'm actually not caring about it. So it just renders there. It moves around from left to right. I created a seeming transition there, so you don't really notice that the animation started again. And I can do here, walk around, can do my things and build things if I want to. And nobody notices, and I can just simply interact with the game normally, but the camera feed here renders it in a bit, like just renders here without me noticing. This is very useful for live events or and live streams when you want to do them. I hope this video helped you to grasp what you can do with FicsIt-Cam and how you can use it to improve your YouTube videos or even live streams. There are a lot of more features that we may consider to add, especially in regards of quality of life for the editor, but also some other features. You already may have noticed there are a couple of bugs here and there, for example, in regards of the camera feeds and when you render something that the image the image is not quite right. Here and there some bugs. We are working on them, and if you have if you find yourself some issues or whatever with the modification, please create a GitHub issue report on our GitHub page for FicsIt-Cam, or report them on our Discord server. So we have a channel section for FicsIt-Cam on the FicsIt Networks Discord channel, on the FicsIt Networks Discord server. So please tune in there to also talk with other content creators that use this mod. So then everything that is left to say is thank you so much for watching. Please leave a like and a comment down below. I was Panacotononol, and I say bye bye until next time. And as always, keep coding!